Welcome dear student and Jai Swaminarayan. Today in this video we will discuss the last topic of the chapter number 4, soap and detergent. Both the things soap and detergent we are used in our daily life to remove the dust particle from the cloth, to remove the oily particles from the cloth, right? So how the soap and detergent is used to remove the dust particle from the cloth? What happens when the soap and detergent are mixed with the water particles? Which type of the reaction taken place when the detergent containing water containing a detergent added with the dirty clothes, how the dust particle dirt is removed from the cloth, we will discuss in this video. So first of all dear student, we discuss what are the soap. So first of all, salts are a long chain sodium or potassium salt of the carboxylic acid. Like for example, sodium stearate, right? The molecular formula of the sodium stearate is a C17S35 C double bond ON. Here, dear student, we know that the carboxylic acid, makes a reaction with the base. It forms the salt of the carboxylic acid, right? So, long chain of this type of the carboxylic acid, with the help of the long chain of the carboxylic acid, salt of the sodium or potassium of carboxylic acid, we can form a soap. So salts are nothing but a long chain of the sodium or potassium salt of a carboxylic acid. So for example, if we considering a sodium stearate, right? In the sodium stearate, 17 carbons are there, 35 hydrogen atoms and C double bond Na, that means it is a sodium salt, right? So the name of this C17S35 C double O Na is a sodium stearate, right? Long chain of the carbon compounds. 17 carbon atoms are connected in a long chain. In the one of the carbon carboxylic group of the COONA is connected, carboxylic group of the salt is connected to this, right? So this long chain of the sodium or potassium salt of the carboxylic acid forms a salt, right? See, this salt is very helpful, right? Let us see the structure of the soap molecules, right? Soap molecules is a structure, has a two part, a long hydrocarbon part where the carbon and hydrogen are connected. So here the first part of the soap molecules is a long chain hydrocarbon part, which is a hydrophobic, water repelling and soluble in a oil and grease, and short part of short ionic part, which is a hydrophilic, water attracting and insoluble in the oil and grease. So dear student, here the soap molecules, long chain of the sodium and potassium salt of the carboxylic acid. So long chain, in this long chain two parts are there. First part, a long hydrocarbon part, which is a hydrophobic, water repelling part. So this part of the long chain of the hydrocarbon, which contains the carbon and hydrogen molecules, right? This long chain hydrocarbon parts is a water repelling part, which is soluble in a oil and a grease, right? And other short part of the soap molecules, ionic part is there, right? Short ionic part which is a water attracting, that is called the hydrophilic, right? So here the soap molecules has a two parts. One part is a long hydrocarbon part which is called the hydrophobic, which is a water repelling part. The long hydrocarbon part which is water repelling part is soluble in oil and grease, right? And second part is a short ionic part which is a hydrophilic, which is water attracting part. It is insoluble in a oil and grease, right? Now how the cleaning action occurs? Cleaning action of the soap molecules. So in the soap molecules of the cleaning when we added a water soap molecules in the water, it has the two types of the part, long chain hydrocarbon part and second short ionic part which contains the Na plus ion, right? So when the soap molecules are immersed in the water, right, it are the soap miscellaneous entraps the dirt particles. So long chain hydrocarbon parts are connected with the dirt particle, right? So dirt particle, oil or grease particles, right? The long chain hydrocarbon part is connected to the dust particles, right? So when the soap is dissolved in a water, like this, when the soap is dissolved in a water, it forms a spherical structure called the micelles, right? So this type of the spherical structure of the soap molecules is called the micelles, right? So when the soap is dissolved in a water, the molecules of the soap forms a spherical structure which is called the micelles, right? So in each micelle, the soap molecules are arranged radially such that the hydrocarbon part, long hydrocarbon part is towards the center and the ionic part is towards the outside. So when the soft micelles form such that the long hydrocarbon part is towards the center of the soft micelles. So soft molecules are arranged like a radially in a circular form such that it has a two parts. We know that it has a two parts. So long hydrocarbon part is towards the center, right, and the ionic short ionic part is towards the outside. So when the hydrocarbon part dissolve the dirt, so when in this type of the water soap solution, when there is a dirt particle is there, the hydrocarbon part dissolve the dirt, oil, grease and forms the emulsion at the center of the micelles which can be washed away by the water, right? So when this type of the radially soap micelles occurs when the dirt is at the center, the hydrocarbon part dissolves the dirt, oil and grease and it forms the emulsion at the center of the micelles which can wash away by the water, right? So this type of the part dissolve hydrocarbon part dissolve this type of the dirt particle, right? And this dirt particle is uh, washed away by the water. So dear student, understand how the cleaning action occurs by the soap, right? So let us see the again revise the soap. Soap are the long chain sodium potassium salt of the carboxylic acid. When the carboxylic acid react with the base, it forms the sodium and potassium salt of the carboxylic acid. So in the salt of the carboxylic acid, sodium ion and the potassium ion is connected to the long chain of the hydrocarbon, right? Like for example, sodium stearate. In the sodium stearate, 17 carbon atoms are there, 35 hydrogen atoms are there, and connected with the C double bond Na. So this Na, that is for the sodium salt. So this type of the salt is called the sodium salt of the carboxylic acid. Similarly, you can form a potassium salt of the carbolic acid also, right? Now, what are the structure of the soap molecules? The soap molecules has a two part, one long part and one short part. A long part contains the hydrocarbon part. It is called the hydrocarbon part, which is a hydrophobic. Hydrophobic part of the soap molecules is a water repelling part, right? And the hydrophobic part of the water solution, soap molecule is a soluble in a oil and a grease. Second part like this type of the long part is a chain of the carbon and the hydrocarbon. So long hydrocarbon part is a hydrophobic part, right? This hydrophobic part is a water repelling part. It repels by the water molecule. Second, short part. Short part is a short ionic part. It contains the Na plus ion, sodium ion, potassium ion, and this part is a hydrophilic part. That means hydrophilic part. That means the ionic part of the soap molecule is a water attracting part. The ionic part of the soap molecule is insoluble in oil and grease, right? So when the soap is dissolved in the water, it forms the spherical structure called the micelles, right? So in the each micelles, all the molecules of the soap is arranged radially such that the hydrocarbon part, long hydrocarbon part is towards the center and the long short ionic part is towards the outside, right? So now this hydrocarbon part, this type of the micelles occurs with the dirt, right? The hydrocarbon part dissolves the dirt, oil, grease and forms the emulsion at the center of the micelles. And this emulsion at the center of the micelles which can washed away by the water, right? Understand the cleaning action of the soap. Now second one is the detergent. Detergent are a long chain sodium salt of the sulfonic acid. So detergent soap are a long chain of the sodium or potassium salt of the carboxylic acid, whereas the detergent are the long chain sodium salt of the sulfonic acid. Soap do not wash well with the hard water because it forms insoluble precip precipitates of the calcium and magnesium salt in the hard water. So soap do not wash the well with the hard water because it forms the insoluble precipitates of the calcium and magnesium salt in the hard water. Whereas the detergent was well with the hard water because it does not form the insoluble precipitate of the calcium and the magnesium salt in the hard water. So detergent was the well with the hard water, whereas the soap do not wash well with the hard water. So there is some difference between the soap and the detergent. So what are the difference between the soap and detergent? First one is the soap are the sodium salt of the fatty acid, carboxylic acid, right? Soap are the sodium or potassium salt of the fatty acid, or we can say that the carboxylic acid also. Whereas the detergent are the sodium salt of the sulfonic acid. Soap clean well in the soft water but do not clean well in the hard water. Whereas detergent clean well with the both the hard water and the soft water, right? Understand? So the cleanliness occurs in the detergent is a well compared to the soap. Soap do not clean as well as the detergent. Detergent clean better than the soap. And last difference is the soaps are the biodegradable and do not cause the pollution, while some detergents are non-biodegradable and it causes the pollution, right? So soap are the biodegradable substance which do not cause the pollution, while some of the detergents are non-biodegradable is cause the pollution and it is harmful to the living beings, right? So dear student, I hope that you understand this last point of the chapter, soap and the detergent, and what are the difference between the soap and the detergent. Thank you very much for watching my video.